Okay, now we're going to practice differentiating each function, log functions and exponential functions with respect to x. So remember the rules. If it's a log or natural log function, it's just 1 over whatever that function, the original function, times the derivative of the function. And for an exponential, e to the x, and let's actually call this g of x. It's just e to the g of x times the derivative of g of x. All right, so let's get started. The derivative of the natural log of 5x cubed, we're going to take, I'm just going to write this tells the reader that, hey, we're going to take the derivative. So notice that's all I did here. All I did here was announce to the reader that we're going to be taking the derivative of each side. And the derivative of y can just be rewritten as dy over dx. Now, the derivative of a natural log is 1 over the original function times the derivative of that inside function. So the 3 comes down. 3 times 5 is 15. 3 subtract 1 is 2, so it's 15x squared. And then notice, 15 and 5 have a 5 in common. 5 goes into 5 once. 5 goes into 15 3 times. X squared and x cubed, that goes away. And 2 of those go away, leaving x to the first. So it simplifies to 3 over x. All right, let's go on to the next one, e to the x. So notice I'm going to do this again. E to the something, the derivative is just e to that something times the derivative of that something. So we have a lot of something in there. So the derivative of y is, well, we rewrite this part, and that's what we did right here. And now we're going to take the derivative of that right there. So the derivative 4 is 0, so we can ignore that. There we have all that stuff again. And then it's 1 over x squared times the derivative of x squared, which is 2x. And then we're going to simplify that. So that x can go away, and that can go over. One of those can go away, leaving us, all of this becomes just 2 over x, and that's going to be brought around in, that's going to be brought in front. And this is what it simplifies, 2 over x times that original e to the 4 plus natural log of x squared. All right, and I think there might be, a couple more. So now we have an exponential function where the base is not e, but the process is the same. If you've got a b to the x, you just multiply it by the b to the x times the natural log of that base. And remember, even when it's e to the x, or even call it gx, the derivative is e to that gx, and it really is the natural log of e times the derivative of the exponent up there. But the natural log of e just cancels to 1, so nobody ever writes that part. So the natural log, the derivative of a exponential whose base is other than e, it's the exact same process. So we're going to, when we take the derivative of y, first thing we're going to do is rewrite all of that. And now it's the natural, we're going to multiply it by the natural log of the base. Well, the base is 3, so the natural log of the base, and I put that down below, and then the derivative of the exponent piece. So 3 to the 4x squared times the natural log of 3 times, and what's the derivative of 4x squared? 8x. Now, some of you might get in a hurry and make a huge mistake. You might want to multiply 8x times 3. You cannot do that because remember, this is a package deal. And because there's an exponent up there, we can't simplify 3 to the 4x squared. And because we can't simplify this, we can't do multiplication. So be really, really careful about that. The only thing we're going to do is this 8x is going to be brought around in front, and then this is as simplified as that's going to get. This next one is a little bit more complex. You're going to need to apply the laws of exponents first. So what we're first going to do is simplify all of this stuff before we can find the derivative. So notice this 2 is going to come down in front. Because it's on the outside of both of those, there's going to be the square bracket. And then when things are being divided, that's going to expand to subtraction. And then remember each individual piece. When we take the log of 4x squared or cubed, the 3 is going to come in front, and it's going to be 3 times log of base 2 of 4x. That divide expands to subtraction, log of base 2, and this, all of that's going to go in parentheses. Now that we've done all of that, we can go ahead and take the derivative of all of that. All right, so we're going to leave the 2 out in front. And then remember, this is just, we're going to treat it very similar to the natural log, right? So it's 3 times 1 over 4x times the natural log of the base number times the natural log of 2 times the derivative of the 4x, which is times 4. Then we've got a subtract sign, and we've got, so it's going to be 1 over this function times the natural log of this base number, so the natural log of 2, times the derivative of x squared plus 3, which is just 2x. And then you're going to simplify what you can. So notice this 4 and this 4 are going to cancel. 2 times 3, we can go ahead, oh, and I think I left off a piece over here. Oh, and I just am not multiplying that yet. So that cancels, leaving 3 over x times the natural log of 2. Subtract, none of this stuff will cancel. And notice you see these little kind of blurred out marks. We're going to want to find the common denominator. So what they do share is the natural log of 2. What they don't share we're going to multiply top and bottom here by x. And notice the left side doesn't have this, so we're going to multiply top and bottom by that x squared plus 3. And then we're just going to do the math of all of that. So 2 times 3 times x squared is 3x squared. 3 times 3 is 9. Subtract x times x is x squared. And all of that, now they're going to have the same denominator. They're going to have an x times an x squared plus 3. And then it's going to be multiplied. They share the ln base 2. These two things can be combined. So our final answer, I'm just leaving the 2 on the outside. 3x squared subtract 2x squared is x squared. So x squared plus 9 all over that shared denominator now. And that's it. That's all there is to it.